All right, so this is a lab exercise that was developed to help students with understanding equilibrium. And so specifically in this project, students build and then analyze the static mechanical principles of a 3D tensegrity structure. This takes one lab period, so it's really manageable. Then and they have this 3D structure that they create, and then they do post-lab calculations. And if you were at ASEE and you played along there, you saw I do have a laser cut version of this that unfortunately I don't have to show you here myself today, but I can show you some images after that can be adapted anywhere you have a laser cutter. So this could be done in class as opposed to in a lab if you wanted to explore that in a class where you don't have a dedicated biomechanics lab. So my outcomes for this project, I was targeting a couple of gaps. We had a understanding gap. Students were really struggling to understand exactly what was happening with equilibrium. And so they got the idea that it was balanced, but moving from this sort of 2D static equilibrium that you do in your physics class into now thinking about the body, thinking in 3 dimensions, and thinking about equilibrium that is static but dynamic because it adapts to this, right, is a tougher ask of them. So we were looking for some way to bridge that gap while at the same time kind of filling some time. So our biomechanics lab ran concurrently with our biomechanics lecture, and we could never get those sections to sync up exactly. So we needed to fill some time at the beginning of the class. So I conceptualized this project with the hope that we were going to introduce students to some new tools and along the way help them feel more comfortable approaching the more advanced tools that they were going to come across later in their education. And also help them really make some physical meaning of what is equilibrium and how does our dynamic equilibrium in the body adapt. And in order to do this, this project has a couple of really simple steps. So we started with tool safety training. Obviously, we're not going to take students around power tools without making sure that they are prepared and we are prepared. The students get into the wood shop and they get to cut, they get to drill and really make their pieces. And then they have to put those pieces together and assemble them and balance it out. And this is not a non-trivial exercise. So this is the place where they really get to experiment with the forces as they're building out their pieces here, which we'll look at in a second. And then lastly, they do some analysis. So they look at what are the forces? They have to actually calculate what's the volume of the structure, what's the density of the structure, where is the center of mass of the structure, and then from that, figure out what are the forces that are acting on these strings that are holding it together. So for those of you who are unfamiliar with the idea of tensegrity, tensegrity exists when we have structures that are made of purely compressive and purely tensile elements. And so this image in the top right here is Buckminster Fuller. He sort of conceived of and did a lot of work with tensegrity. And he's also very famous for the Epcot ball. So we can kind of introduce it to students that way. They're familiar with Spaceship Earth, which is less related to this actually, though similar in structure and the shape that he's showing there. So what's really cool about this is tensegrity models. Tensegrity is a great model for how our body is composed, right? We have our bones, which students may not be familiar with our bones as mineral moderators, right? Or for some of the signaling, like chemical signaling properties that they have in the body, but they are familiar with their bones as the structure that holds up their body. And so this is a really base way that we can get into this idea of compressive and tensile elements. And we can also talk even further about how inside the cell, right, our cells themselves are a model of tensegrity. And so we see our actin cytoskeleton pushing against this 2D fluid of our cell membrane created by the semi-permeability there. And we can talk about all different ways that we see these equilibrium structures exist inside our cells. To develop this project originally, I was not going to start completely from scratch. So I watched this very short, which is linked on here, and I'll share these 2.5-minute video on YouTube that kind of gave me the base idea of how to put this together. And then I started messing around with dimensions. I chose to go with wood because I wanted to increase students' comfort with tools. but I also wanted them to get a hand on subtractive manufacturing. So one of the questions that someone had asked me when I presented at ASEE was, why not just use the laser cutter, or why not just 3D print these? And we do a lot of 3D printing. Our students do a lot of 3D printing. It's fantastic. We can make really precise designs. But something that's lost in that is all of the things that we learn in subtractive manufacturing, right? And so if we're going to make something for these larger frames, if we're making out of wood, if we're machining with CNC mills and lathes and things, right, we have to think about what material is lost there. And so this gave an opportunity to talk to students, not only about using the tools, but also about what are we thinking about when we measure? What are we going to lose? What is the kerf going to be, when we're using a saw? And how do we think about making our measurements in that way? So thinking about those design elements to help us with prototyping later. And I also chose the wood shop because I'm just more comfortable in the wood shop than I am with any sort of metalwork. So that was the logical place for me to go with this. I did outsource our safety training to the Power Tool Institute. So the Power Tool Institute is a trade-backed institute supported by a lot of different power tool companies, or funded by a lot of different power tool companies, that provides comprehensive tool safety training units online. And so we use that, and we use the quiz that was provided with them to make sure students were prepared to step into the lab with this. So we started out with sort of that first design that I showed you a few slides back. And this image here on the bottom is actually what this project looks like now. Our first iteration of this was a pilot that I did with 8 students in the spring of 2023. And now we have successfully taught this for 6 semesters. This past semester, we taught this to almost 200, I believe, undergraduate sophomores across both locations of our Purdue campus. So I'm really excited that we've been able to scale this up. And along the way, we've come up with some great adaptations for it. So we are now connecting our tools with dowel. So students are learning about dowel jigs and using drill presses. And we're also playing around with the idea of students actively applying weights to the top of this. So if I can jump back here for a second, this image on the left-hand side that came from the template video shows them balancing a plant on top. And originally, when we first made these, we would make them. Students would try to put all sorts of things on top of them. It was a lot of fun. One of the latest adaptations is to use, in this image here, scored acrylic. And so students can place weights at different distances away from what they've calculated to be the center of mass of the figure. And then later do calculations to check their theoretical values against the actual values that they got in class of where a weight would need to be, what that moment is generated when it's moved away from the center of mass. And we also have students model this in ANSYS now. And so they're able to model it in ANSYS and apply forces in different places and see how that changes things. So we've made some great additions and iterations, and that is absolutely with the help of the team that is teaching this now. So I conceptualized this project. Violet taught it with me for a few semesters, and then now Violet and Michael Linus teach it and are responsible, along with some incredible TAs, for a lot of the improvements along the way.